Hello, this is David Hillier here, and I'm going to be giving a short video on capital budgeting. It comes from chapter 7 of my book Corporate Finance, and I'll be discussing nominal and real cash flow investment appraisal. The key thing in this video is that you're consistent in the use of cash flows and discount rates. So if you're using nominal cash flows, that is cash flows that include inflation, then you should use a nominal discount rate. If you are using real cash flows, that is cash flows where the inflation rate effects have been stripped out, then you should use a real discount rate. And that is the key message in this video. And I'm going to take you through the processes of basically carrying out an investment appraisal with nominal cash flows and an investment appraisal with real cash flows. You'll be glad to know that the values you get at the very end are the exact same. It's just the way that you get there that is different. So, three things that we'll be talking about. We'll be talking about the formula that you need to use to go between nominal discount rates and real discount rates. We'll be looking at the impact of inflation on cash flows, and then we'll just undertake this capital budgeting analysis. So this is a formula here, and what you have is you have uh, the real interest rate is equal to 1 plus the nominal interest rate divided by 1 plus the inflation rate minus 1. You can mess about with that actually so that you can also express this as 1 plus the nominal interest rate is equal to 1 plus the real interest rate multiplied by 1 plus the inflation rate. And there is an approximation to this formula. It's only when you're doing back of the envelope type analysis. If you've got a spreadsheet program, you should always use the exact formula that's the one at the top there. But the approximation is that the real interest rate is equal to the nominal interest rate minus the inflation rate. So it's quite a simple formula, and the approximation is quite simple. When you're dealing with very small inflation rates or very small interest rates, the approximation is surprisingly very close to the actual formula. And the reason is that the compounding effect is really quite small when the actual values are small. So if we look at an example, you can see here that we're got, well, let's focus on the rates first. So you have a real interest rate of 3.8% and inflation is 6%. If we were to use the back of the envelope calculation, which was the real interest rate is equal to the nominal interest rate minus the inflation rate, then given that we've got the inflation rate of 6% and the real interest rate of 3.8%, then that would give us a nominal interest rate of 9.8%. If we were to go through the actual calculation, then you would find that the correct value would be 10%. So the nominal interest rate is 10%, the real interest rate is 3.8%, and the inflation rate is 6%. So let's just look at how, we come to the same final point, but we go through two different routes. If we're using nominal interest rates, then £1,000 invested in a bank at 10% gives you 1,100. The inflation rate was 6%, so we would discount this 1,100 by 1.06, and that gives us a value of 1,038. That's this formula here. Now, what we did is we did the nominal interest rate, we had the inflation rate, and we ended up with 1,038. If we were to just use the real interest rate directly, then it's 1,000 invested at the real interest rate of 3.8% is 1,038. So you've got the exact same endpoint. It's just the way you go is different. And you can see here, these are the values that we've been using. That's the exact value, and that is the approximation value. So they're quite close, but not not as close that it would always give you um, the same value. And I would say that if you're doing back of the envelope stuff, then fine. But if you're doing work that's is professional, even or for an exam, then you really have to use the correct rate. So I've spoken about the difference between nominal rates and real rates. We're now going to be looking at cash flows. So a nominal cash flow is the actual money that you receive in the future. And that actual money is the cash that you put in your pocket. It's the physical cash. The real cash flow is the equivalent value of the cash based in today's terms. That is the value of the cash once you've taken inflation into account. And if we look at this example here, it's a fairly nice and succinct example of what the difference between nominal and real cash flows are. So if we start off, you see that you're going to have this novel which is available in 4 years, and novels currently sell for €10 per novel. Now, inflation is going to be 6% a year over the next 4 years, and novels are so popular, so you're also expecting that the prices will rise by 2%. So let's say then, well, okay, so the prices are going to grow by 8% per year. So what would the price be in 4 years' time? Well, it's just the price today multiplied by 1.08 to the power 4, and that gives you €13.60. You're expecting sales of 100,000 copies, so the amount that you would expect to get in is 100,000 multiplied by 13.60 euros. Now, is this a nominal cash flow or a real cash flow? Well, because this cash flow has incorporated and it includes a component for inflation, then it means that it is a nominal cash flow. The equivalent real cash flow is the cash flow amount divided by the 1 plus the inflation rate to the power 4. So the real cash flow is 1.08 million euros. The nominal cash flow is 1.36 million euros. And this is us going back to the rule. The rule is that if you're using nominal cash flows, you should use the nominal discount rate. If you're using real cash flows, you should use the real discount rate. So some quick examples before we finish. We have three cash flows, and these are nominal. These are nominal cash flows, and the nominal discount rate is 14%. The inflation rate is 5%. So what's the value of the project? Well, if we're using nominal cash flows, we use the actual cash we get in. And you can see here, it's a simple net present value formula where you're discounting the cash flows in years 1 and 2. And you're given a net present value of 26.47. Now let's move to looking at this from the real cash flow perspective. With the real cash flows, you're discounting the future cash flows by 1 plus the inflation rate to the power t. So we were told that the inflation rate is 5%. You can see that here. So discounting these cash flows of 600 and 650, you end up getting real cash flows of this amount. We also need the real discount rate. The inflation rate was 5%. The nominal rate was 14%. So using the formula that I introduced earlier on in the video, we have a real discount rate of 8.57143%. So we undertake the same NPV analysis, and you can see here that with real cash flows and real discount rate, we have an NPV of 26.47, which is the same as the nominal cash flow analysis. So we get to the same point, but we take two different paths. And as long as you're consistent, that's good enough for the analysis. This is a bit more of a complex analysis. What we've got is we've got the capital expenditure, and then we have revenues, and these are all in real terms. So these are real cash flows. We have the cash expenses, and then we have depreciation. So we're told that inflation is 10% per year. The nominal rate is 15.5%, the tax rate is 40%. So what we're going to do is, as long as we're consistent that we discount nominal cash flows with nominal discount rate, then it's fine. And in the previous slide, these were real cash flows. So we now need to create nominal cash flows. So you see the nominal cash flows is what we're doing with the inflation rate of 10%. We have nominal cash flows, nominal revenues, nominal expenses, nominal depreciation. The taxable income is as such. We then multiply this by 40% to get the tax, and then we get the net income here. Now, to get our cash flow from operations, we've got to add the depreciation back in. And adding the depreciation back in, we have value of cash flow for year one is 869, and in year two is 968. So we now use these cash flows with the nominal discount rate to find the NPV. And you find that that is €268. Now, let's do the analysis again with real cash flows and real discount rate. The inflation rate is 10%, the nominal rate is 15.5%, so using our formula, it gives us a real rate of 5%. So we use the real cash flows in this slide. You see that we're not incorporating inflation here. We end up with real cash flows, operating cash flows, and it's these cash flows that you discount by the 5% real discount rate. Using the simple NPV formula, you get the same NPV of €268. So the key message in this video is be consistent, use nominal cash flows with nominal discount rates and real cash flows with real discount rates. Thank you very much.